What I've got on that is one of the key challenges with tubular steel is achieving connections that are both structurally efficient and visibly unobtrusive. For this project, we aim to keep all the joints as neat and compact as possible so that they would not detract from the elegance of the overall structure. To achieve this, we obviously used a 3D package, which is very common in this day and age. We have a lot of clevis connections. We've also looked at the connections required from an erection point of view and tried to detail them in a manner that is structurally sound to keep Andrew the engineer happy on everything, as well as then keeping the erector happy because the connections are accessible and easy enough to get bits and pieces of steel into position and bolt them together up in these high elevated areas. I'll give you my take on that one. The project's location in Johannesburg's historic CBD had a major influence on both design and construction. The site's tight urban context made transporting of the long items very complicated and difficult. We made columns which are 24 meters long. It was a decision we made to fabricate those to the full length in the workshop so that we didn't have any site joints. But obviously then getting the long items onto site was very difficult through Joburg CBD. We overcame this by using steerable dollies to carefully navigate through the city centre and the tight 90-degree corners that exist there. And everything actually worked out very well in the end.
I think on that one there, just to add, it's always in a computer model, everything looks nice and you can scale everything so it fits the page nicely. But when you see the truck pulling out and weaving its way through downtown Joburg, you really get a good feel for the scale of those things. So I appreciate what Tuss did on that to make it there, because as Martin said, the other options were trying to field bolt something or do field welding, but these are very long, very tall, very slender columns. So getting them, making sure that they're 100% straight was very important, both structurally and also for the installation tolerance. So it did create a bit of a headache, but I think it was worthwhile. I think it's always this fun balance of trying to blend the architectural intent with the site conditions, with the fabrication challenges. And I think it's typically it's normally done just through a collaboration process with trying to keep the architect in the room and the fabrication the fabricator also, and keep the engineering at the same time, and try to interact with all people involved to try and make sure that you don't lose the design intent as you go in, and you pull in knowledge and experience from the different people that are involved. So I think it was quite clear up front what the architect wanted. They wanted a very clean, lightweight skylight. They wanted to create a beautiful atrium space below, and they wanted to reduce impact on the existing building. And then everything we did, us and Tuss and our installers, everything we did was keeping those three things in mind. And I think having a steel fabricator like Tuss, which could understand these things and then work with us on the connection details and that, I think that made the process a lot easier. Yeah. I think just on the tubular steel side, a big thing with this skylight is the architect wanted it to be quite a clean looking skylight with not too many, you get some projects where the purpose of the project is to look at the structure, and you get other projects where the purpose is to create a space. And this was a project where the purpose was to create an atrium space. So they wanted everything up there to be clean and not fighting with the existing structure. So we went with tubes. Because they can, you can create the geometry, you can create quite neat connections. It doesn't form too many shadow lines. It doesn't look intricate. It looks pretty uniform from the different angles that you look at it, and it's good. It's good for torsion, which we needed. I was going to say, I think a lot of in terms of sustainability, a big part is, you know, reducing the embodied carbon, reducing the impact of new build, but almost as important or more important is how do we make existing structures work for the current application? And I think that's this project. I would say that's probably the main thing that stuck out to me was they had a great building, they had a good site, they had a lot of heritage in the building, and instead of tearing the whole thing down and building something new based just on the requirements now, it's a question of how do we take what we had, how do we, you know, celebrate the things that work well, how do we retrofit, change things, and how do we tweak the structure so it can meet the current needs. So I think on the sustainability, you know, that the whole, you know, 3 R's, reduce, reuse, recycle, the main thing is not the recycling, it's the reuse. It's the how do you use what you have in an efficient way. So I think that was, to me, the part that we were trying to focus on. And a part, I think, from the construction industry is we've got an industry where we have got quite a few older buildings. And I think we need to look very carefully at how do we make these buildings fit for use based on updated code requirements and you know, creating spaces that people want to be in. I think the building's got a very important function, and I think it's important that it's a building and a space people want to be in, so then they can bring their best part to it. I think in the built environment, a lot of it is we're creating spaces where other people can do a lot of things. So it's almost like it's like a multiplier. So if we can create great spaces in a sustainable way, the people who use those spaces can hopefully can be inspired and do a better job at what they do. So that's kind of where, that's what we think the biggest value add was for this project.
We explored several approaches to improve the efficiency and performance. We utilized jigs to have accuracy and consistency of repetitive components. All the circular hollow sections were ordered from mill rollings to avoid having unnecessary joints and lengths over 6 meters, and also avoid excessive waste. These strategies all allowed us to enhance constructability, optimize material use, and deliver a precise, high-quality finished structure. So all in all, I think it all worked out very well there.
Yeah, and I think just on adding on to that, I think when we were looking at the design, we were trying to look at how do we optimize things. And I think the optimizing is what we often see is people sub-optimize one part of the building, and then that's super efficient, but then the other part's not efficient at all. And I think what we tried to do on this here with TUS was to optimize the system and not the individual components. So we were trying to come up with a grid that made a lot of sense structurally, but it also worked very well for the cladding, which in this case was ETFE, which is ethylene tetrafluoride ethylene, which is it's a very lightweight cladding material. And one of the, when we look at these structures, we've developed an embodied carbon calculator a couple of years ago, where we can look at the embodied carbon on the specific element that we're working on. Because I understand there's obviously the whole building but we just focus on our little parts of the building. And one of the things which we found very useful, specifically in this case, was we could create, so with an ETFE and with a lightweight steel structure, we've actually got a lot less weight of steelwork. And then which obviously helps on the steelwork side, it helps on the material, it helps on the erection side. And then on the cladding itself, it is a recyclable material which has got a fairly low embodied carbon. So overall, it's a very efficient system. And then the sort of knock-on effects as well, so we just look at that at the part, but the knock-on effects is you've got a lot lower reactions onto the building. So the sort of negative, the effects of reducing the amount of piling needed, the effects on the existing building. So that was some of the things that we were trying to look at, was to try to make the overall system very efficient.